Explain the concept of electrical resistance. So before going the deep discussion, uh, concept of electrical resistance. Electrical resistance is a fundamental property of the materials that describes their ability to impede the flow of electric current. It is represented by the R, represented by the resistance R, and the measured in ohms. Resistance is a crucial concept in understanding how electricity behaves in circuits and electrical system. So here is the some breakdown of the concept. First one we'll discuss is the definition of the electrical resistance. The definition: electrical resistance is the opposition encountered by a material to the flow of electric current when the voltage applied across a material. The electron within the material experiences resistance as they move through it. Next one, causes of resistance. Causes of resistance. Resistance arises from the various factors within the material. It can be the material properties. If the material properties, the different materials offer the different level of resistance. For instance, metals like the copper have low resistance, while insulator like the rubber have the high resistance. Next one, temperature. In most materials, resistance increases with the temperature. This is due to the increased atomic vibration, which impede the movement of the electrons. Length. Longer conductors generally have the higher resistance because electrons encounter more obstacles as they travel through the material. Next one, cross-sectional area. Greater cross-sectional area typically results in the lower resistance because there is more space of electrons to flow. That is we have the formula, that is R is equal to rho Lya. Next one, we have the Ohm's law. Resistance is a fundamental component of the Ohm's law, which states that the current flowing through a conductor is directly proportional to the voltage applied across it and inversely proportional to the resistance. Mathematically, Ohm's law is expressed as V is equal to IR. V is the voltage, I the current in amperes, and R is the resistance in the ohms. Next one, effect of the circuits. Resistance plays a crucial role in determining the behavior of the electrical circuits. It limits the amount of the current that can flow through a circuit for a given voltage, affecting the overall performance and the functionality of the system. Next one, the power dissipation. When current flows through a resistor, electrical energy is converted into the heat energy due to the resistance encountered. This phenomenon is known as the power dissipation, and the power dissipation P is equal to VI. P is the power dissipated in volts, V is the voltage in volts, I is the current in the amperes. Importance of electronics. Electronics. Understanding the importance is essential in designing and analyzing the electronic circuits. Resistors are commonly used components to control the current flow, set voltage levels, and divide the voltage within the circuits. So these all are the importance of the electronics. So in conclusion, we can say that electrical resistance is the measure of the material's opposition of the flow of current, influenced by the factors such as the material properties, temperature, length, and the cross-sectional area. It is a fundamental concept in the electronics and the crucial for the analyzing the designing in the